Okay. Can you hear me? Good. All right. Hello, everyone. Welcome. Thank you for coming along. I'm aware that my voice sounds a little bit odd. I'm all the way from New Zealand. I'm apologizing now if I kind of keel over. I got in the day before yesterday and I'm slightly bit jet lagged. Today's talk is on Java API design best practices. So if you're here for a talk on web services or how to do RESTful URLs, I'm sorry to disappoint. That's not what we're going to be covering today. We're going to be talking about how to do public APIs in the sense of if you have a jar file and it's packaged up with public classes and a whole bunch of implementation, how we have a good API in that sense. So like I said, my name is Jonathan Giles. I just call myself a Java guy at Microsoft. There's not very many of us. It's getting better. I mean, so my job at Microsoft is, I've come in from Sun and Oracle. I was there for a very long time working on the JDK, and my job at Microsoft is one, to go out and talk to people like yourselves, but primarily it's actually to focus internally to make sure that the SDKs that we put out to our users, such as yourselves, if you're using Azure services and using the Java SDKs, my role is to focus on making sure that that experience is as good as possible. So I'd love it if you emailed me with any complaints or feedback. You can contact me, jonathan.giles@microsoft.com, and I'm on Twitter @JonathanGiles. So like I said, I'm Jonathan. I'm from New Zealand, hence the accent. I worked at Sun and Oracle for a very long time. I actually joined Sun just before it got gobbled up by Oracle, so that was kind of mid-2009. And at that point, I joined to work on what's known as JavaFX. I don't know how many of you are familiar with JavaFX. It was the UI toolkit that was built to replace Swing, which itself replaced AWT. And so it was a really fortunate time to join Sun because I was working on a brand new UI toolkit from the scratch. So I kind of got to build everything from the ground up. It wasn't like I was coming in to maintain Swing, for example. I was building the UI controls and the UI toolkit for JavaFX. But what I really enjoy about my job is that I get to focus on developer experience. I get to care about all the things that cause friction for developers and how to get rid of that friction. So it's making sure that we've got really good APIs, but it's also making sure that we have good documentation, good samples, good code repository practices, all those kind of things. So today's talk is going to be largely about the API side of things, but developer experience encompasses so much more. I'm just curious if I could see a show of hands of people who are using JDK 11 today, either in code or practice. Right, 2 hands. What about 10? Okay, a dozen or so. A very vigorous hand wave down the back there. What about JDK 9? Okay, so most people, I guess, are on JDK 8? Yeah. So it's always very informative when I do this, because everyone in the room kind of gets the same information. Who's on 7? Who's stuck on 7? No? 1? Who's on 6? 1. And anyone suffering before 6? Okay, so that's really interesting for me because I kind of was on Sun and Oracle from about JDK 6 through to 11. I left Oracle late last year as we were kind of getting ready to put out, I guess, JDK 10, and I joined Microsoft pretty much immediately after that. And it's interesting because lots of people, I guess, haven't jumped that chasm into the module land of JDK 9 and beyond, which is what pained me for many, many years. So this talk has been given a few times now. I've given it 2 times now. And it was split between API design theory and some more practical advice. And every time I give it, people say, don't worry about the practical advice. We're all kind of decent Java programmers. We want more on the theory side. So I keep on trending towards the theory. Yesterday, I sat down with a slide deck, and I kind of just completely threw it out, and I redid it to focus more on the theory side. I hope you like it. If not, my email address is there, and let me know. Who here has read this book? Okay, so 30. Who has read the 3rd edition of this book? Yeah. So I highly encourage everyone who's a Java programmer to consider reading this effective Java book. It's written by Joshua Block, who's very well known for doing a lot with the collections framework back in Java 1.4 days. This is the 3rd edition. It came out about a year ago, and it focuses on all the releases, but especially 8 and 9. So it covers a lot with streams and functional interfaces and the like. Highly encourage everyone to sit down and read this book. Expense it to your manager. Yeah. So let's just get on with it. Let's get into API design theory. So one of my teammates drew this picture, and I thought, well, I'm going to co-opt it to make a metaphor. And API design is kind of like being the first kid into the sandbox. You come up to the sandbox that's completely flat, and it's your job to make something that is rewarding, enjoyable, and fun for the other kids in the playground. If you're not a sandbox person, I'm not personally, think of yourself as Dungeons & Dragons, Dungeon Master, whatever floats your boat. We're kind of the god of this world. We kind of make the rules that the other kids have to play with. So an API is what some developer uses to achieve some task. It abstracts away a whole bunch of implementation. We don't have to worry about how the networking code connects through the web. We don't have to worry about how the collections API does all its work with arrays to grow and shrink as necessary. We just kind of use the API to achieve some task. So we have two key questions. Who is the user of our API and what are their goals? And we're going to dive into both of these throughout this talk. One question I like to ask at this point is, who in this room is an API designer today? And if anyone's watched my slides online, I know people have come up to me about that. It's kind of a trick question because what I want to say is that we're all API designers. If we write any public class and inside that public class have public functionality, public methods, we should consider ourselves API designers. Whether it be just for ourselves, whether we're just writing code for ourselves on our fun weekend project, or whether we're doing an open source project, or whether we're doing it for enterprise, or for myself with the JDK, for millions of developers around the world, it doesn't really matter. We're all API designers, and we should have a focus on API design quality that probably extends beyond what we do traditionally. So there's a whole bunch of characteristics which you can use to categorize or characterize a good API. This is my set. Feel free to disagree with any or all of them. It's kind of what I use to review API. But we're going to dive into each of these in quite a bit of detail over the next few slides. But just briefly, API has to be understandable. It's pretty obvious. It has to be well documented. It has to be consistent. Has to be fit for the purpose. That's making sure that we're targeting the user and the level of the user. Has to be restrained, which is probably the more controversial topic that we'll talk about shortly. And it has to be evolvable. We have to kind of have a vision for how it's going to evolve over time, and we're going to have to make sure that we don't box us or back ourselves into a corner. So how do we make an understandable API? How many of you have added a dependency to your Maven POM file, or however you do your dependency management, and you've had the jar download into your IDE, and you've kind of scratched around inside the jar file, trying to work out how to get started with this particular library to make use of it to do some particular piece of work? And even if you can find the class that you think might be the class that you have to use, then you find a constructor or a static factory or some singleton, some way of interacting with this class. And if you find that, do you find that there's arguments that you have to give to the constructor that are then other classes that you have to become familiar with? And it's kind of going down this rabbit hole of trying to understand this API that's just becoming more and more complex as you go down the rabbit hole. So what we want to achieve is an API that is intuitive to developers as best as we can. It's not always possible to have just a single entry point into an API. Some projects do that very successfully. Others, by their nature, can't. So what we want to try to achieve is an API that doesn't have to give external documentation to the user just to get started with the API. And what we want is an API that's consistent. Well, I'm going to hammer on about consistency over the next few slides, but it's really, really important to have a consistent API, because when you break consistency, you're breaking the trust that the user has in your API. So an example would be if you have half a dozen classes and they all do similar things one way, and then that one other class does it a different way, or a different method does it a different way, the users are going to stop trusting you to be doing the consistent thing all the time. And always when a developer comes to your API, they're not coming to your API to use the whole API at once. They're often coming to it just for one small slice of it. But over time, their needs may grow and they'll use other parts of it. And if it's consistent across the board, they're able to intuit the new functionality based on their experience with the old functionality. So one way we can be consistent is we can have a plan to only have a minimal set of return types that we return. This isn't always possible. Sometimes we need to return all kinds of return types. But what I mean is, if we have a bunch of methods that all return some kind of collection, can we have a minimal set of collection types that we return? Can we only do it with a list and set, for example? Some APIs you see have list, set, iterator, iterable, stream, collection, and the whole lot. And it forces the developer to have to come up with different ways of dealing with the API based on the return type of the method. Another thing is, and I don't want people to get confused about this, I'm not saying never return null, but if you choose to not return null for a certain return type, so for example, if you have methods that have a return type of list, and you choose to say in some of them that this will never return null because you just return an empty list, you should try to be consistent across your whole API for the return type of list to never return null. It's not to say you have to choose to never return null for all your methods. Some APIs quite happily return null. It's just try to be consistent for a specific return type. I should just note, I see some people taking photos. Feel free to not take photos. These are all up online. I'll post a link at the end of this presentation. So returning null enables null pointer exceptions to crop up. There's some general rules that we can use to not return null. If you have a return type of string, you can instead return an empty string. If you have a list set, any of those kind of collections classes, you can return an empty list. So the collections class has a whole bunch of methods to return empty list, empty set, empty map, these kind of things. It's far better to return that than null, because if a developer is going to get a result back from your method that's a collection, rather than having to null check, they can just do their for loop or whatever they want to do with that collection, and because it's empty, they'll just fall right through and carry on the other side. Stream has stream.empty. Array, you can return an empty zero-length array. And we're going to talk about optional later. I get a lot of discussion with people about optional, and so we'll dive into that a little bit later on. It's a funny thing, that class. Judging by the laughter, I think you would probably agree. Method name is another interesting thing. You wouldn't believe the amount of pain and agony we would go to inside Sun and Oracle to come up with naming conventions for all of our API. It's really important to kind of come up with this vocabulary of how you're going to name things, whether you want to have some kind of odd naming pattern, as long as you're consistent. That's the main thing. Developers want to be able to pop up their IDE autocomplete and to see what they expect to see when they type in whatever your vocabulary is. So it might be you use the type.of syntax, or value of, or to XYZ, or from, or you just use a standard Java Bean approach. The main thing is that you, as an organization or a developer, have a consistent vocabulary that you use for methods, arguments, constants, types, etc. This kind of is an obvious one. I'm reticent to talk about method order. Argument order, because you should all be doing this, obviously. If you have overloaded methods, or even they're not overloaded, if there's just a bunch of methods inside a class, it makes sense to have the same ordering in all of them so that developers don't get confused. If the argument size becomes large, or even if it doesn't, one approach that a lot of developers use, I've never personally used it, but I've been beaten around the head in previous presentations about the concept of argument types, which is basically a wrapper around a set of arguments that go into a method. And that means you can grow the argument type over time to have more arguments. If you think that in the future releases of your API, you're going to have to overload your API to have more arguments, it's better not to do that and to have an argument type that wraps it, because you can easily add more fields to the argument type and do it that way. So moving on from consistency to fit for purpose. We have to make sure that we target our API to the right level. And the example I always use is the new date-time APIs that shipped in Java 8. I kind of should stop calling them new date-time APIs because they're not really new anymore. But the good thing about them is that it was targeted specifically for people like you and I. We're just standard programmers. We don't need to know the nuances of all the different calendar systems in the world. We shouldn't have to deal with all the different time zones to get the work done that we just want to do, which is typically doing relatively simple maths with date and time. So if you're familiar with where the new datetime API came from, it came through the JSR 3.10, but it was originally Joda time, and that was a far more complex API. It had a lot more functionality in it, including all the different calendar systems from around the world. And as part of the process to come into the JDK, a lot of it was simplified and removed to make it more focused on the requirements that we as developers have, but it also cuts down the API size. So the thing we should be doing when we're an API designer is we should be working out what the one thing is that we want to do well, and we want to make sure we understand the user and their goals. We could very well have a date-time API that's simply along that's milliseconds since the epoch. That's a perfectly serviceable API for some people. On the other hand, we could have one that forces the user to know all about calendar systems, time zones and the like, and that's probably a perfectly serviceable API for some subset of developers, but for us as general purpose programmers, that neither of those would be the ideal outcome. So I saw this tweet the other day. It's from Scott Bollinger. He said on August 23rd, "At this point in my career, I understand that a feature that only takes a few hours to build can create hundreds of hours of support and maintenance in the future. Just because it's easy to build does not mean you should add it to your product." And obviously, he's talking about products and features, whereas I'm talking about more SDKs and APIs, but the concept is still a valid one. Don't add API just for the sake of adding API. When I first started at Sun and Oracle, I was doing exactly that. I was writing API because I thought, well, if I add this method, it's going to save developers having to do this and this. I was very fortunate at that time to have a mentor who said to me, "Do you really need this? Why do you need this?" And to kind of challenge every single method that I added into the API. Now, we don't all have to do that for all of our projects. The JDK is kind of a special case in that sense because once you get API into the JDK, you don't really ever get it out. It's kind of there forever. And it's things you wish you could fix that you can't fix. In the case of open source projects, that is probably not so important, but it's still important to understand that API has a cost, and you have to make sure that it pays its way. So we don't want to just make sure that we make developers' lives easier by having as much API as possible. That has two concerns. One is developer overload. I don't know how many of you have popped up in IntelliJ autocomplete pop-up that gives you 500 methods, and you kind of have to search through them for the functionality that you want. Hopefully, in that case, the vocabulary that we've discussed previously helps. That it kind of makes it more easy to kind of filter down for what you're looking for. So we don't want to just have all API because it increases developer overload, but we also don't want to have more API than we need because it increases our burden. So try to invert this desire. Try to work on yourself to say, why do I need this? Why should I add this to my API? And that's not to say that we shouldn't have convenience APIs, that we should only have the very minimal set. There has to be kind of a gut feeling that we develop over time to work out where the convenience should be cut off. So an example of convenience API that's good is things like the new list.of API that landed on the JDK recently, which lets you make an immutable list in just a single line of code with a varargs number of arguments, or list.add, which everyone takes for granted, but if you didn't have list.add, it's kind of a convenience API for list.add with an index and the object. And no one ever wants to specify the index unless they've got a special case for it. So these kind of convenience APIs make a lot of sense. The main thing is to just keep challenging yourself to work out where that where the convenience layer is right. Don't have too much and don't have too little. This is where people strongly disagree with me because I look at it from an API designer point of view and other people look at it from a developer point of view. I like using the final keyword. Final is not used enough, in my opinion. When you have a variable, obviously you just make it final if you're not going to change it. But if you have a class or a method, make it final. It means that you're in control of that class's destiny as opposed to the person on the other side who's going to come in and subclass your class and monkey patch in some functionality so that they can achieve what they want to do. And then later on when you do your next release, you're not able to do it without them complaining in your ear about it because they did something that they shouldn't have done. Final is a way for us to take back control. We can always take away the final keyword when we're happy that the class should be subclassed or the method should be overridden, but by default we can have it in there and we can kind of own that a little bit more. It kind of I'm sure all of us are practicing good OO in terms of having private modifiers. Don't make everything public. I won't go on about that. Fields should rarely be public. They should always be private. I've never really come across API that has good protected functionality in terms of protected methods. Unless you're really designing it in from the get-go to be a class that you want to be subclassed, and there are good examples of that, it's very hard to kind of have an API that is retroactively able to be subclassed by adding in protected. There's better ways to do it, but if you are going to have protected API, make sure that you write a lot of subclasses that do exactly that. They subclass it and they do something that extends it in a meaningful way. Very often, even in my own cases that I regret, you can have protected API and then the result is that people start saying, well, I want more and more and more. And what they end up actually asking for is a whole bunch of your private methods to be made protected. And it's kind of like a virus that invades your classes that slowly makes everything protected or public, and it's not very nice. So it's very important that we understand what is our public API and what is implementation. So there's really two different ways we can do this. We can have an impl package or an implementation package or an internal package, something that kind of delineates public API from private API or private implementation. Those of you familiar with JDK 9 will understand that modules came along and made all of the com.sun packages invisible, basically. The modules just don't export the com.sun packages. And that's why most of you are on JDK 8, I presume. So a lot of my last few years was basically working out how the hell we're going to solve the problem of everyone depending on com.sun API, and trying to move as much of it into public API in a meaningful way before JDK 9 released and broke the world. So the nice thing about having an impl package or implementation package is that you can do the same thing under JDK 9. You can just choose not to export that package as part of your module declaration, and that means it's completely invisible to developers using IDEs. And it won't be available at runtime, it won't be available at compile time. It's very nice. It's very nice from an API designer's point of view to be able to say, don't touch this code, and actually being able to prevent it. Because prior to JDK 9, developers were using com.sun just as if it was public API, despite the warnings forever. The other option is to have a package private class. So you basically have all your implementation classes as package private, and they sit in the same package as the public API, and they're just not visible by virtue of the fact that package private classes aren't visible to any class outside of that package. And either approach is good because it hides away the implementation. We really don't want to have implementation leaking out through our public API, but the first thing we have to do is make sure that it doesn't leak out just by the fact that it's visible in the API packages. When it comes to reviewing Javadoc, it's a really good idea to make really careful note of any implementation classes that are leaking out through the public API. So we're going to talk a lot about Javadoc soon. And kind of extending on from leaking out implementation details, the next thing that we have to be careful about is not leaking out external dependencies. So if our library depends on RxJava or OKHTTP or whatever the case may be, we don't want to have a return type that returns that or an argument into our method that accepts these types unless we specifically have decided that that's okay for our API. Once we have done that, once we have returned it or added an argument into a method from these external dependencies, we've kind of tied our project and that external dependency together as part of our API surface area. Obviously, coming from the JDK, we didn't have external dependencies, obviously, but in open source projects and the like, if you do, it's okay. It's okay to do that, but you just have to make sure that you're doing it intentionally. And again, this is a really good thing to look at when you have your Javadoc generated. One option you have, if you actually find that you have leaked something out, is to create a wrapper class that wraps around that return type or that argument type and return that wrapper type instead, or have that wrapper type be what's passed into the method so that you're not leaking out the implementation details. So the next thing is being evolvable, and that really is having it's a few things. The first thing is having a clearly stated policy on backwards compatibility and deprecation. I'm a big fan of semantic versioning. I hope you're all familiar with semantic versioning, but basically the concept is don't break things outside of major releases. So that's the first number on the version number. So what you can do is basically up until a major release, you can add deprecated annotations to your API. On the major release, you can delete all the deprecated methods, do what you want to do, add new functionality, and that can be your break-in release that you've done. It's a really good idea if you do choose to have a deprecation and backwards compatibility policy to document that on your website or however you communicate with your users. I guess the other point to make is we don't want to be breaking builds all the time. We don't want to be causing grief for our users all the time. So we want to have a policy that says we will break this intermittently when we have to make our offering better. Coming from the JDK, obviously, we basically never broke the API, but in my own open source projects, I'm quite happy to break API. It kind of is the balancing act to have between being an engineer who just wants to make things better and being an engineer that doesn't want to break everyone else that's relying on you. So there's a balancing act that you have to have there. So there's this concept I like to call the journey to 1.0.0. It's kind of the point that we cross this threshold from being experimenting with an API and an implementation to putting something out there that we kind of are happy enough with, that we think is good enough. API design is really, really cheap. I don't know, I sit down all the time inside my IDE and I start sketching out APIs that I think could work. And you start adding a few public classes, a few methods inside them, and you kind of build up this API in a matter of minutes. And it's really easy to kind of tear it all down at that point and build it back up in a completely different fashion. So it's really important at this point, when it's really early on, when no one's using your API, that's the perfect time to experiment with API. And it's a really good time to not just experiment with the API, but actually do what's known as eat your own dog food. Be the first user of your API and make sure that you're happy with the API as well from a user's perspective. And we're going to talk a lot about that in the next slide. So the big thing really is having developer empathy. Looking at problems through your developer's eyes, or not just solving the problem that you have to solve, but making sure that what you're offering is solving the developer's problem as well. Write a lot of sample code that uses it and discuss it with real users. And that's a really good time to look for things like unclear intentions, duplicate redundant code, or an abstraction not being at quite the right level. Next one is documentation. I'm a huge fan of documentation. When I start open source projects, I kind of have as the criteria for the open source scene of it that it's going to have good documentation. If people want to do a pull request into my open source projects, I require really good Java doc as part of that pull request. I think I like the Java doc to be the single source of truth for a project. It's the best place to have clarity on how to use an API. So I love to see a Java doc that makes use of all those annotations or Java doc tags, things like @c, @since, @link, things that add a richness to the Java doc that's generated. Include code snippets. I love seeing code samples inside the Java doc. And a great place to see these code samples from is actually the bug reports and the questions that you get inside your project. If people are asking questions on a particular thing, that probably means it's not clear enough. So either you need to fix the API to make it clearer, or you need to add some samples into your Java doc, or have a way for them to better understand how to use your API. So this is just a screenshot of the Azure Functions HTTP trigger. Did I mention I work for Microsoft, right? So this is the Azure Functions Java doc. I wrote it the other month. But it's just an example of what I love to see when I see Java doc. It's a full page of text. There's a code sample there, and there's a bit of richness on the bottom about saying when it was added. It was since 1.0.0. And just at the very bottom it says C also, which is telling the user what other classes might be interesting for them. It makes me really sad when I see Java doc, because a lot of people ask me to review the Java doc. And so I go Maven Java doc, or Gradle docs, or whatever the case might be, and I generate the Java doc. And it makes me really sad when all I see is the generated output from Java doc with no comments written by the developer. That makes me unhappy. The other nice thing about Java doc is it allows for a place for us to specify behavioral contracts. We can't easily specify a behavioral contract as API, but Java doc's a really good place to do that. So, for example, arrays.sort, it guarantees that it's a stable sort, which basically means if it's sorting a whole bunch of data inside your arrays and it finds two equal things, it's never going to swap them around. They're always going to be sorted in the order that they were found. So it's something that we can't have as part of our API. We could call it arrays.stablesort, but if there's a whole bunch of behavioral contract, you're not going to have a super long method name just to kind of clarify all the behavioral contracts that you're fulfilling. Java doc is a really good place to fulfill this contract, or to specify this contract, I should say. The only problem is that this becomes part of your overall API that you're promising to the user. If you start adding, if the authors of the arrays.sort functionality all of a sudden took out that behavioral contract and they didn't guarantee it was going to be stable anymore, there'd be a lot of angry Java developers. It's a contract just as much as any API is. And I've said this already. It's a really good place to review APIs in the Java doc, because the Java doc removes all the code, all the implementation details, and it just shows you method names, class names, arguments, and the like. So it's a really good place if you have to review API to generate it, to look for things that don't feel right, that are missing or incorrect, or things that are leaking out. So if you're accidentally leaking out implementation details. And another thing that makes me sad about projects when they ask me to review their Java doc is if I go Maven Java doc, and I generate it, but it fails because they've got warnings and errors as part of their process. It just means that people aren't generating Java docs regularly enough. I do this consistently, and one of the things I've been doing at Microsoft over the last few months is just Every single Java SDK has a Javadoc build that I run, and I review it on a weekly basis. And if it fails, I'm just firing pull requests in to make sure that it continues to build. We should always have building Javadocs. This is something that hurt me a lot a few JDK releases back. Don't do what I call negative examples. And I'm kind of aware that I'm saying do not do negative examples, but don't write code that say, or don't write Javadoc documentation, or even any documentation for that matter, that says you should never do this. This is a dumb idea. Don't do stuff like that, because we live in a Stack Overflow world these days where developers see code and it's the highest rated code on the page. They copy and paste it, they put it into their IDE, they run their app, and they either find the bug straight away and they email you and they file bug reports and call you an idiot on Twitter, or they find it a few months later and they spent hours looking for it first. So a large proportion of my bugs for some JDK releases were people saying, I did what your Javadoc says and it doesn't work. So this is an example. I had to go back a few releases. I'm sorry you can't quite see it, but it says at the very top, a warning about inserting nodes into the combo box items list. This is strongly not recommended. For example, never use the following code. You should do the following. And I got so many bug reports and so many people calling me an idiot on Twitter about that first chunk of code, that 5 or so lines of code, because no one bothered to actually read the text around it. So as I'm talking about how important Javadoc is, just be careful that people are looking for code snippets and how to get things done. So just be careful. Don't do what I did. Don't be an idiot like me. So the next thing is, it's really handy if in developing all this vocabulary and consistency approaches to everything that we want to have in our API, if we're a part of an organization that's more than just ourselves, having some kind of team-wide cheat sheet, some living document that we can share with the new hires that is being driven by the whole team, so that we have a consistent plan for how we're going to write API. And we want to have a document that not only exists, but it's a living document that encourages feedback and discussion on how to improve over time. Our goal is to get everyone moving in the same direction. So in conclusion, there isn't a magical process. It's not engineering. API design isn't engineering. There's no kind of inputs in and perfect API out. It's something that is more like an art. And that's why I like API design, because I spend all my days writing code, but every now and then I get to pop up and write API. It's like exercising the other half of the brain. It becomes easier with practice. It becomes even easier if you have someone more senior than yourself kind of saying, why are you doing this? Are you sure that this is right? And even if they don't have any knowledge of the API, just being asked and challenged is a really good way to kind of form this gut feel. All right, practical advice. When I first wrote the slide deck, I had 20 tips. Now I've got 4. We're going to go through them and we'll see where we end for time. And it's kind of jarring, because we're jumping from a whole bunch of theory stuff, a whole bunch of thou shall do this, to a whole bunch of code samples. So just prepare yourselves. So first one I want to talk about is static factories. Static factories are great because they offer 3 main benefits over constructors. They have the ability to be named. Obviously, a constructor has to have the name of the class. They do not require a new instance to be created. Obviously, if you call a constructor, you're creating a new instance of that class. And they have the ability to return subclasses. And obviously, if you call in the constructor, you're returning an instance of that class. Sorry, about the second one, require a new instance to be created. We can return, for example, a cached object, and we'll see that on the next slide. And we've been using static factories for a very long time. I'm sure many of you have seen API like this, the boolean.valueof method inside the boolean class. You pass in a primitive boolean, and it returns back a reference type of true or false. Now, this might not seem all that useful, but it's got a few benefits. One, it's got a nice name. Boolean.valueof is a lot better than new boolean. But more importantly, it allows you to return a cached object. So in this case, you're returning a cached object of true or a cached object of false. If you had a tight for loop that was doing some kind of operation, it was reading in a million objects or something from a database, and you had to call new boolean a million times, you'd be creating a million boolean objects. If you called boolean.valueof, you'd be creating 2, but they already existed, so you're actually creating none. So it's just a far better way to do some things that have not just an API design win, but also a performance win. And speaking of performance wins, List added a whole bunch of API. One I particularly like is list.of, which allows you to create an immutable list with just one line of code. So you can call list.of, or you can call list.of with one element, list.of with two elements, 3, 4, 5, 6, 7, 8, 9. And if that doesn't work for you, there's a varargs as well. And we may look at this as API designers, now that we're all API designers after all, and say, why are there so many overloaded methods? There's 12, 13 of them for list.of. Wouldn't just the varargs be okay? And the answer is, from a performance point of view, calling the varargs approach requires an array to be created to store the objects that are passed into it. And so there's a performance implications there. And for the most common cases where you create an immutable list of 10 or less elements, actually just having the overloaded methods makes a lot of sense. So part of API design is not just looking at from a purely, what is best from an API perspective. Part of it's looking at it from a wider perspective in terms of maybe security, but often performance. And this is one of those cases where if you asked me if I was happy as an API designer, I'd say no, but I would accept it because I think it's the right thing to do. So let's just create a random int generator. It's going to be a class that creates an integer that's randomly assigned between a given min and a given max. We don't care about the next method. We're API designers. Implementation's beneath us, right? Let's have a constructor that takes the min and the max, just assigns it to the fields. That's no hassle. Let's create another constructor that takes the min. In this case, we're saying we want a random integer between the given min value and integer.max value, which is way off in the distance. We can create another constructor that has the max value, and the min value is going to be way down at integer.min value. And if you're paying attention and you're running a Java compiler in your head, you'll see that this is a duplicate method error. It's not going to compile because those last two constructors are the same as far as Java is concerned. So that's kind of where static factories can come to the rescue a little bit. We can add in a private constructor. So in this case, at this point in time, it can't be instantiated this class. And we can start adding in a few nicely named static factories. We can have between, where we pass in the int, min, and max values. We can have bigger than, where we just pass in the min value. And we can pass in max to a smaller than method. So we're benefiting here from having nice names. But we're not necessarily benefiting other than that. It just gets us around the constructor issue. The reason why I go through this kind of process and explain to you something that you should all relatively already know is that everything I say you can disagree with. I'm totally fine with you disagreeing with me. The main thing that we want to achieve today is understand that there's a consideration process as with any API design. We want to make sure that we're always looking through the lens of the developer's eyes, that we have really good API quality and we have high design standards. However you achieve this, it doesn't actually really matter. Just make sure that you're focusing on these aspects. So on to everyone's favor. I heard the laughs before about optional. Who here has written a method that returns optional? All right, and just keep your hands up. Who here has written it and then wondered if that was the right thing to do? Yeah. So I'm always like that. So I write them all the time. I'm like, is that the right thing to do? So hopefully we'll try to clarify a little bit now. For those of you not familiar with optional, it's basically an object-oriented way of trying to avoid null pointer exceptions. Basically, you can think of it as a container that you return from a method, and that method then guarantees that it's going to return a non-null optional. And that container can contain one element or no elements. If it's got no elements, it's considered to be empty. If it's got one element, it's considered to have something present within it. Optional has obviously got a generic type of type T that specifies the element that's going to be in there. It's best used in a select case, and that's really where something might be returned or it might not be returned. And if it isn't returned, the user of your API has to do something about it. They have to do some different action. And optional has all these convenience methods. So let's just imagine that we've got this method that exists elsewhere that's called getFastest, and you pass into it a list of cars, and it's going to return to you an optional of car. So it's going to return to you the fastest car that exists in the given list. And so in that first line of code, we say car, fastest car equals getFastest car. And at that point, when we call getFastest car, we're going to get an optional back. We don't know if that optional's got something in it or if it's empty. The or else method as part of the optional class basically says, If the optional is not empty, return whatever's present inside that optional. But if it is empty, use this value instead. In this case, use car.invalid. So this is some static field that we've created earlier on that specifies an invalid car. So when we go back to the fastest car variable on the left-hand side of the assignment operation, we know that the fastest car is going to definitely not be null. Now, if the or else operation is going to be expensive, we can use the second line of code, which is or else get, where we pass in a supplier, which is a functional interface, so it can be a nice Lambda expression, to do some kind of expensive operation that's only called in the instance where the optional is empty. So in this case, we're doing some search the web operation, which we presume is going to be an expensive and slow operation. But that's only performed in the cases where the optional is empty. For example, if the get fastest method returns is given an empty list of cars, for example, or a null list of cars. We might want to throw an exception. So optional has this ability to or else throw, so for example, a missing cars exception. Or we can do something like, if present, do something. In this case, we're going to race the car. So if the car is present, just race it. That's fine. That's kind of good use cases for optional. If that's kind of what the users of your methods are going to be writing, that's probably a good argument for using optional. Ignoring all the other arguments against optional, those are good arguments for optional. If, on the other hand, all your users are doing is basically doing an object-oriented version of a null check like this, it's probably not a good use case for optional. If all your users are writing is code that basically, this can quite easily be translated back to a null check, right? So we can say, instead of result is present, we can say result equal to null, it does not equal null, I guess, is a result dot start car race. This is basically not good approach to using optional. If those of you who have returned optional find that most of your users are doing this, I would argue it's actually not worth doing. I would argue just return car in this case. And how many of you have written code that does this? Because if you are, you're evil. And in this case here, what's happening is you're guaranteeing to return optional, and you're actually returning null, which is breaking the whole contract, the whole behavioral contract expected of you as an API designer. As we've discussed previously, there's cases where optional doesn't make sense also. If you have a method that's returning a collection, it's much better just to return the collection. Don't wrap that up in an optional collection of type T. Just return an empty collection. It just means that the developer has one less step to go through to kind of determine what's going on. One thing that's new in JDK 8 is obviously lambdas. And lambdas are enabled through functional interfaces. And functional interfaces are essentially a class or an interface with a single abstract method. So it's very enticing when you're writing API to just start creating functional interfaces. And you can create your own functional interface simply by having a class or an interface that has a single abstract method. It's good, if you are going to do that, to annotate it with @functional interface. That means that the compiler is going to ensure that that class or interface only ever will have one single abstract method. And if a colleague of yours or you 6 months down the line accidentally add another abstract method into this class, it's not going to compile. The code won't compile, because you don't want this to slip through the cracks, because anyone that's written a whole bunch of Lambda expressions using your previously functional interface, it will no longer compile. However, having said that, this is one step back, because what I'm wanting to say is in many cases you don't have to write your own functional interfaces. You can use the ones that are built into the Java util function package. There's actually 43 of them. And they can be broken down into 6 categories. So unary operator obviously deals on one element and returns the same type. A binary operator deals with 2 elements and returns the same type. Predicate deals with one element of type T and returns a Boolean. Function takes a type T and returns a value of R. It does some transformation. Supplier simply returns the type T, and consumer takes a type T and returns void. So this is kind of the 6 primary categories of functional interfaces that the JDK ships was. Like I said, though, there's 43 of them. There's a whole bunch of them that are specialized for different use cases, for primitive types and various other cases. And now going back to what I said before, in some cases, the existing interfaces do not always meet our needs. The name might not be descriptive. No one's going to argue that comparator is a really good name for exactly what the comparator interface does. And it's much better to have a comparator than some generic named functional interface. And another reason why you might want to create your own functional interfaces is that it allows you to add default methods and non-abstract methods to your classes, which makes it much more functional for the developer in many cases. So I've already spoken about the functional interface. Make sure you make use of it. Otherwise, you eventually might break your build or break your users. So speaking of lambdas, this is tip number 4. I just really wanted to race through this one. When designing an API, if we are using functional interfaces, consider if we can support lambda expressions. And the simple requirement is that we have a method that takes as an argument a functional interface. And that's the only argument. Sorry, no, that's not true. It has to just take an argument, one of which is a functional interface. And so I think, well, who here has used Swing? Yeah, kind of. I miss it too. So this is a J button that we add a mouse listener to. The mouse listener interface has 5 methods declared on it. This was obviously defined in the days before lambdas were kind of even a glisten in the eye of the designers of that particular part of the JDK. And so that meant that if you wanted to listen to a user clicking on a button, you would have to implement all 5 of these mouse listener methods, whether you cared about mouse released or mouse pressed or not. And obviously, in many cases, you mainly just cared about mouse clicked, for example. So what the Swing developers did was they also added the mouse adapter class. And the mouse adapter class is simply a class that implements the mouse listener interface, but all of those 5 methods are just empty methods, they're just no ops. And then you, as a developer, can come along and create a new mouse adapter, and you can only override the method that you care about, in this case, mouse clicked. Unfortunately, neither mouse listener or mouse adapter are sufficient for writing a lambda expression, simply because the requirement is that there's a single abstract method. And in the case of mouse listener, there's actually 5 abstract methods, and in the case of mouse adapter, there's actually 0 abstract methods. So the Swing developers, unfortunately, had no way to support lambdas, so you'd always be using anonymous in the classes, as you see here. With JavaFX, I don't know how many of you are familiar with it, but it started off as JavaFX script for a long time, and it transitioned into into Java around about Java 6, 7. It's so long ago, it's all blur to me. But we kind of had the forewarning that lambda expressions were likely to be supported through functional interfaces that were single abstract methods. And so we designed our API slightly different. Rather than having a mouse listener, like you see there, where you pass in an adapter or a listener that has many different methods, with JavaFX what we did is we had a more specific method on the rectangle. In this case, we had a set on mouse clicked method. And so this meant that the argument into the set on mouse clicked method could accept a functional interface, because there's only just that one piece of callback that we needed. So in this case, in the first block of code, you can see we're passing an event handler of mouse event. We have a method called handle that takes the mouse event, or that passes the mouse event in, and we can do whatever we want with that mouse event. We can print it out, for example. Obviously, with lambda expressions, we can achieve what's shown at the bottom part of the screen, which is just simply a lambda expression doing exactly the same as the code above. The point of all of this is simply, if you're going to have, it's good to support lambdas if you can. Just make sure that you consider it up front as part of your API design. Try to have functional interfaces. So that wraps up the practical tips. I just wanted to quickly go on about a few different resources that might be useful to everyone in the audience. First one, obviously, is YouTube. Josh Block, who you see there on the screen, he's the author of the book, Effective Java. He's got a lot of presentations online from various conferences around the world. I probably should have blurred DevOps. It's kind of competing, I guess. A lot of good content there. It's well worth your time to kind of search him out, and I'm sure YouTube will suggest other useful things in the process. Snyk is a really good tool for security analysis. If you're writing APIs and SDKs that you want to be certain don't have security issues, Snyk doesn't look at the security of your code. What it looks at is the security of the dependencies of your code. So it looks at your Maven POM file, for example, and it works out all the dependencies that you have. It takes the version details, and it looks through its database to know about any security issues that are related to those issues. It's got free tier. We use it inside Microsoft. We use the free tier for all of the Java SDKs. It doesn't cost anything. There's more advanced tiers for more advanced functionality. Highly encourage everyone to check that out if you're doing any kind of SDK and you're worried about the security of your dependencies. Rev API is an open source tool. It's a little bit geeky. It's basically a library or a tool that allows for you to compare two jar files, whether they come down from Maven or whether they're jar files on your system. And it's a really good tool, and I've used it throughout Microsoft tooling to compare releases to actually understand when the versions are going to be, when the releases are going to have breaking changes, because oftentimes we don't know that we're breaking things. So this is a really good tool to just kind of make sure that you're not accidentally breaking API. Right, just a few useful links. I didn't come all this way from New Zealand to not mention Azure, so feel free to look at java.ms. That's the Azure for Java developers page. A large chunk of my code these days isn't to write code. Oh, sorry, a large part of my work isn't to write code anymore. It's to write documentation, and it's to answer questions and to offer tutorials and guidance to developers. So this is kind of where I spend a lot of my time as well, just making sure that we have the answers to a lot of developers' questions. There's a free tier. There's a whole bunch of free stuff that you get in perpetuity. There's also a whole bunch of credits that you get. It's pretty crazy. I think you get like 1 million Azure functions calls for free, just forever. It's pretty amazing. And speaking of which, this java.ms URL is just a URL that I registered. And it's just backed by an Azure function. And every time it goes into that Azure function, it kind of redirects you to the actual page. So it's pretty cool to play around with. VS Code's lightweight, not quite IDE. I was about to say IDE. It's more of a lightweight editor. It's actually backed by Eclipse JDT. It's written largely by Eric Gamma, who has a lot to do with Eclipse. And it's built by Microsoft. It's an Electron-based application, but it's also developed by Pivotal, Red Hat. And it's pretty cool because I use it a lot for Markdown editing, but it's basically got the concept of a language server. So you can plug in support for Java or Python or whatever languages you're dealing with, and it's just a really cool way. It's really lightweight. You can pop up the editor really quickly. And for those of you interested in the presentation, there's a slightly different URL there. I'm obviously Spanish as well, so Joe Giles /API design. If you want to download the slides, I'll put these slides up from today's presentation, but there's previous presentations where I had more practical tips and less academic advice that you can also check out at that URL. And with that, I'd like to say thank you for your time. All the best. Write the best APIs you can. And if you have any questions, feel free to reach me at jonathan.giles@microsoft.com or at Jonathan Giles. Thank you.